We have two talks remaining before the end of the day, and both would be focused on different aspects of building the infrastructure on top of Kubernetes. And in the first of those two, Andrei Kvapil from Palark will tell us about virtualization in Kubernetes, KubeVirt, and how its networking is working. Andrei, please, your time.
Thank you. Hello, everyone. My presentation today is called KubeVirt, its networking, and how we brought it on the next level. My name is Andrei Kvapil. I do usually architecture solutions based on Kubernetes, design and developing cloud platforms, and as well work a lot with software-defined storages. The main technologies I work today is Kubernetes, KubeVirt, and Linstore. I work at Palark. At Palark, we do DevOps as a service. We provide our technologies and help to other companies to prepare and deploy their software into Kubernetes and cloud-based environments. And that's the thing. We needed a cloud. We wanted to make our own cloud platform, which we could use. What is actually the cloud platform is. The cloud allows you to take the resources, like physical resources, CPU time, RAM, and disk space, and use those resources to cut the virtual machines out of this. So we can have many virtual machines, we can span them and scale horizontally. That's the features provided by the cloud. And of course, we wanted this cloud to be as a service, so anyone could go to our API and use it to deploy their virtual machines. And as well, it should be some kind of platform which could work on premise. So you can install it on your own servers. This cloud should be extendable, so it can work with all technologies we have right now. We use Kubernetes a lot, and we use Linstore for the storage. We want some solution which would work fine with all the technologies we have. And this cloud should provide API interface, because this is really important thing to every cloud provider, to provide well-known and understandable API interface to your customers and integrations. Usually that means that you need to have Terraform support, and such a nice idea that we want to have opportunity to deploy the virtual machines using standard Kubernetes API. Like such a nice idea that you can use standard kubectl command to go public cloud and order the new virtual machines and new services. Okay, so what kind of solution we consider it? We were choosing between only open source solutions because we're contributing to open source a lot. And we considered few solutions before we start thinking which solution we can use. Okay, those three, they're less popular, but they're also interesting. The main problem of those solutions that they have smaller community and they can be controlled by the single company. That's not always good when some open source software, it can be open source, but problem that when it's controlled by the single company, it can do everything with those software. For example, OpenEbula had really bad case when they closed sourced the migrators between the major versions of the cloud. We don't want to have such problems, and we don't want to have the vendor lock-in. And the other problem that it has, they have poor Kubernetes integration. That means that we would to develop a lot of integrations like CSI plugins to make Kubernetes working in those clouds, in those solutions fine. The next solutions we were considering, first we considered OpenStack, of course, because this is like default solution for making your cloud. The problem of OpenStack, well known, it has overcomplicated architecture. If we'll see on the scheme of OpenStack, we'll see a lot of microservices. Every microservice has its own database, and you need to configure it to have connection between each microservice to another one. And as we know, when things complicated, they can be broken very simply. We wanted something simpler. We like this keys principle, like keep it simple, stupid. So the next solution was KubeVirt, but it wasn't also very good. The problem of KubeVirt that it has overcomplicated networking stack. KubeVirt actually tries to reuse all the interfaces of Kubernetes, like CSI, CNI, and CRI, to be able to run virtual machines inside the Kubernetes. But in result, we have this difficult stack inside every pod to connect the virtual machine to standard Kubernetes pod networking. So we found that there is no normal solutions. Probably we need to develop something new. Okay, how we would do that? We would take Kubernetes, because we love Kubernetes. We would take libvirt, because this is main tool and main library for spanning the virtual machines. And we would do that inside the containers. Like, why not? The virtual machines can be running inside the containers. It's like the same thing. But later we decided, that's interesting, but KubeVirt is actually doing the same thing. We don't like the networking, but can't we just fix it? Okay, let's take a look more closer on KubeVirt. KubeVirt is fully Kubernetes-based solution. It's under CNCF project. It has growing community. If we'll consider all this, if we'll compare all these projects I was talking before, the KubeVirt has even more stars on the GitHub than OpenStack has. And what is important, the big players, if we'll see who's contributing into KubeVirt, we'll see such companies as Red Hat, NVIDIA, RAM, and OpenSUSE. And this amount of big players, it's growing every year. That's really cool. As can we see, it has community-driven development. It's like Kubernetes. There is no single owner of this project, but many different companies contributing to this project. So we have no this problem when someone could cut off some piece of it, like to remove database migrators, for example, as it was with OpenNebula. And KubeVirt has simple and understandable architecture. It's like standard Kubernetes operator. How it looks like. First, the KubeVirt is virt operator, who is deploying the 4 microservices. Is virt API, who is used for controlling all the API requests to the virtual machine. So using virt API, you can connect to the virtual machine console and do some other interesting stuff. The virt controller, who is implementing standard controller pattern in Kubernetes. That means that you have custom resource in Kubernetes, kind virtual machine, and virt controller will manage this resource. And the next one is virt handler. This is a special entity who is deployed as daemon set on every node and ensure the all needed permissions. It's actually reconfiguring the pod to be able running the virtual machine. And the virtual machine virt launcher is like Go binary, who is running libvirt and virtual machine inside the pod. Actually, every virtual machine in KubeVirt is running inside the pod. How it looks like. If we have virtual machine, we need to take care about few things. First is how it will be running, like how it will utilize the resources, CPU time and RAM. That's what the Docker provides us, the runtime plugin. The next thing we should care about is Kubernetes storage. It's how it will utilize all the resources of the storage subsystem of Kubernetes. That's what the CSI interface provided. And then latest thing we should care about is how it will be connected to the networking. As we know, Kubernetes has really different logic of the networking. This is different from side of view of traditional virtualization platforms. Okay, let's have a look first how we run the virtual machines. For example, we have a node. Inside the node, we have virt handler daemon. I can remember that this service is deployed as daemon set on every node. When we run the virtual machine, the new pod is created. In this pod, we have virt launcher service and virt handler, who is having the full access to the root file system and to the node. It configures the virtual machine pod, which is normal unprivileged pod. It is actually managing the C groups, the network. It creates network interfaces and in passing through the devices. If you need some GPU inside the virtual machine, or I don't know, SRIOV device, it will do the same thing before the virtual machine is launched. Later, the virt launcher is running the libvirt, which is running the virtual machine. So we can see that every pod is running its own libvirt daemon, who is controlling just the single virtual machine. So in this way, we can see what will happen if we'll run the live migration. For example, we have node 2 with the same virt handler daemon. When we start live migration procedure, the new pod is created, and it is configured the same way like the previous one. It is passing through all the devices and configuring the network interfaces. Then virt launcher running the libvirt and starting the migration procedure, live migration of the virtual machine. When live migration is finished, the old pod is getting destroyed. So in this way, we can see that pod is just specific entity which is needed to run the virtual machine. Okay, now we know how KubeVirt creating the virtual machines. Now let's see how it is operating with the storage. As can I remember, I told you that KubeVirt tries to reuse all the Kubernetes entities. And in this way, it's reusing its CISA interface the same way like you do that usually. So when we have a node, we run the pod, we can specify specific volumes which should be attached to this pod. So when virt launcher is running, it creates specific volume devices inside of these shares, and they can be accessed directly from the virtual machine. But the good question, how we can make volume hot plugging working? We all know that pod spec is immutable and we can't add new volumes to the pod. So how is it working how it works in case of KubeVirt? Very simple, it just creates new pod. Yeah, first let me explain you another thing. So volumes can be file system mode. The KubeVirt also changed the spec of the CSI a little bit, so you can use block volumes inside the Kubernetes. It's like the raw block devices will be mapped directly into pod. In this way, you will have faster access to your block devices and better performance. In this way, many storage providers also allowing you to do read-write many, so you can use block devices and access them from different nodes, and that makes working the live migration working. So let's back to the hot plugging. The new pod is created. If you want to attach some volume to the virtual machine, the new pod is created on the same node side by side to the pod which is running virtual machine. Then virt handler see that this pod is created and passing through this device to the pod which runs the virtual machine. The same way we can do the next pod, and we can attach the same way so many devices as we want to. But good question, if when we run virtual machine, we need to spawn it from some image or golden image. If we speak about OpenStack terms, it says like golden image. It's like image containing the operating system, predefined and pre-installed the operating system. How we can upload it into Kubernetes? because for now it does not provide any interface for doing that. KubeVirt has additional microservice which is called containerized data importer, and it's like separated operator who's separating this specific entity with specific custom resource which is called data volume. And in spec we can specify how big volume should be created and where to take the image. Actually, it can be some HTTP source, the same way we can store it somewhere in Docker registry. So when we create data volume resource inside Kubernetes, it spawns PVC, standard persistent volume claim, who's binding to the persistent volume. And then the new pod is created, who is taking this image from HTTP in our case, and unloading it to our persistent volume actually. So later we can just connect it to our virtual machine and use it as is. This way, KubeVirt operating with storage. And now we can speak about the most interesting part and the most difficult is Kubernetes networking and how KubeVirt tries to consume it. When we speak about KubeVirt networking, there are two things which we have to think about, is backend and frontend. The backend means that when we create the pod, how the interfaces how interfaces are created for this pod. Usually that's our standard CNI plugin. When we create Kubernetes cluster, we can install some CNI plugin, and this is the same CNI plugin used for everything. That's called pod networking. And the next option is Multus. Multus is a Kubernetes extension which allows you to specify another CNI plugin, or as many as you want, and attach it to your pods. And the next thing, when we create and when we run the virtual machine, is how we connecting the top interfaces of the virtual machine to the interfaces of the pod. And here we have few methods. The basic one and default one is called masquerade. It's just passing through all the traffic between those two interfaces, and it works just with the pod networking. Let's see how it works inside. For example, we have node with physical interface. Then we have pod which runs the virtual machine. For this pod, like for any other pod in our cluster, the wedge pair of interfaces is created. It's like virtual wire who is connecting the pod networking namespace with the node networking namespace. And there is some CNI magic. We actually don't care how the CNI plugin is acting, because we mostly interesting about what is happening inside the pod. Inside the pod, we have bridge. This bridge is created by the virt handler, and the virtual machine connected directly to this bridge. And between the bridge and wedge interface of the pod, we have masquerade rules, which means just standard IP tables rules, who is redirecting all the traffic between those two interfaces. Kind of complicated, isn't it? Of course, we also have DHCP server running inside the pod, and this DHCP server is managing just a single virtual machine and providing providing the IP address and routes to this virtual machine. The next mode is even more, I wouldn't say that it is more difficult, but it is even less performant, because masquerade isn't performant as well, and slurp mode is standard QEMU user space networking mode. For make it working, we can see the scheme, same scheme. We have virtual machine, and to redirect all the traffic from outside pod to the inside the virtual machine, we have QEMU process who's binding to the TCP ports, which you also have to specify in virtual machine spec. And all those ports will be redirected to the virtual machine. But to be honest, this mode is really has poor performance. Slurp also can be used just with the pod networking. The next mode is more universal. It's called bridge mode. That's actually the mode I showed you in the beginning of the presentation. How it works, it actually just connects the virtual machine with the interface of the pod directly through the bridge. We have the same scheme. We have pod, wedge interfaces, CNI plugin. We have virtual machine, and then the bridge, who is connecting the pod and virtual machine, the pod interface with the virtual machine interface. In this way, when virtual machine running, it getting the same IP address of the pod, but in this way we have the better performance of all existing modes. This mode can be used the same way like for Multus and for standard Kubernetes networking as well. The next mode is SRIOV. Yeah, I was little lying when you say that it is most performant. The SRIOV, the most performant mode. But the problem of SRIOV, that it works just the physical function devices. In case if you have network card which can be split to multiple virtual cards with own PCI interfaces, they can be passed through to the pod. And then virtual machine will just start using it as is. But for using this mode, you need specific configuration and you need specific networking cards who will support this. There are also another mode which called MacVetUp. And MacVetUp can work just with the Multus because it relies on specific CNI plugin. It allows you to connect the interfaces directly to the physical interface of the node. So to make MacVetUp working, you need to use specific MacVetUp CNI plugin. You can't use it as default for your Kubernetes cluster. You can use it like just for additional interface to your virtual machines. And it works the next way. When we have pod, the interface, MacVetUp interface created for and attached directly to the physical interface of the node. And since this is the same tap interface, it can be used directly by the virtual machine. That works nice, and it works everywhere. You don't need to have specific hardware for that. But problems of this mode that it works just with the Multus. And you have all these features of the Kubernetes networking as we get used to have, like Kubernetes services and policies. So we decided to little bit enhance this mode and to teach KubeVirt using the, just a second, using MacVetUp, but use it not for the Multus, use it with pod networking. And we actually don't use Multus at all. So how we did that? We have standard Kubernetes networking scheme with wedge interfaces. We have CNI plugin, who is controlling everything inside the node. And when we create MacVetUp device for the virtual machine, it's connected not to the physical interface of the node, but it is connected to the wedge interface of the pod. So when we run virtual machine, it can be directly use. It can directly use the same wedge interface as pod have, and actually it has the same almost native performance if we would use if we would create MacVetUp interfaces instead of wedge. We also have another interface which is used just to provide DHCP to run DHCP and provide correct IP address to the node, to the virtual machine. So we changed KubeVirt in this way and found that it is working, and it works really nice. We use CNI, Cilium CNI, so we have policies and we have Kubernetes services networking, and we don't need to use Multus at all. The isolation is performed by the policies. If we'll compare these three modes, we have two resources with Flannel and with Cilium, and any case, we can see that this MacWeb mode we developed has the less latency than the others. It might be not seen. The first one is MacWeb, second is bridge, and the last one is masquerade mode. But this is a good question if we trying to consume the CNI interface. We have this problem that we can't live migrate the virtual machine because every node has the pod CIDR assigned. And when we create the pod for, I don't know, any pods we create on this node, they have specific address from this pod CIDR, from this subnet who is assigned to this node. So when we create the virtual machine, it also gets the IP from this pod CIDR. So we can't easily live migrate it to another node because the other pod will have another IP address. And when we perform the live migration, the virtual machine should be somehow updated or notice that the IP is changed. Hey, you should to release and gather new IP address. So another patch we implemented is reattaching the network card because virtual machine should know that IP address is changed. And sometimes it is also important to notify that MAC address is changed. So after the live migration, the virtual machine do reattach and new DHCP request for the IP address. That works nice, but we want something more smooth. We would like to not touch the virtual machine at all. So we introduced the new CIDR. We called it VM CIDR. It's just specific CIDR from which the virtual machines get the IP addresses. We patched the Cilium a little bit for make it working. So when you run the virtual machine, the new pod is created. It gets IP address from this VM CIDR. And we also have another microservice who is routing /32 subnets just for this pod through the correct node. So when we have the virtual machine and when we start the live migration of it, the new pod is created. This pod has actually exactly the same IP address. So in one time, in the same cluster, we have pods with similar IP addresses. But the routers routing the traffic only to the correct node. When the virtual machine is migrated, the routers also changing their routes to route through the correct node. In this way, it works more smooth. Later, the old pod getting destroyed. So in a final, we got really interesting system. We got native pod networking works with KubeVirt without any multus, without any extensions. We can use native pod networking for virtual machines. We have all the features enabled, like Cilium network policies, services. As well, you can use standard load balancers for route your traffic to the virtual machine. And we have fastest binding, MacWeb instead of this big and ugly chain of the bridges. We have working live migration, and when virtual machine is live migrating, it's not changing the IP address. And for managing all of this, we have specific custom resources for managing the virtual machines, images, and disks for it. That's actually it. Here are few links for understand this concept better. You can see my previous talk about what the difference between traditional virtualization platforms and cloud platforms. Here are a few links for community channels. KubeVirt is open project, and you can join to the community meeting. Actually, every Tuesday, you can come and ask your questions or just to talk with developers. And here are a few proposals. We proposed to implement these features into KubeVirt. They're not merged yet, but if you're interested in having this functionality in KubeVirt, you can come and upvote to them. Thank you, my colleagues who helped me to prepare this nice presentation. They were listening to me and giving some suggestions. And here it is. Now I'm ready to answer your questions.
Thank you very much. For those of you who are watching us on remote, we accept questions through the Telegram chat. And we have one from the audience.
Thank you for presentation. Can you tell real-life cases when people use this kind of virtualization?
We have interesting client. We not start working yet, but it is quite huge client. He wants to implement VDI based on KubeVirt. He wants to run Windows 11 servers with passing through the GPU, and those GPUs also should be created not from the NVIDIA grid, but using GVM technology, which is allowing to split physical GPU to many virtual ones and run the virtual machines using it.
And they can't implement it in classic containers, yes?
Those technologies can work with classic containers, but they want to run Windows. And it is not easy to run Windows in containers, I guess.
Thank you.
The best question, as chosen by Andrei, would be awarded a prize. And the question through the second row.
Hi, thank you for your speech. So, deriving from your first slides, your plan is to provide cloud for customers based on Kubernetes. And do I get it correctly that currently there is no way to provide a networking service based on Kubernetes? And
what do you mean by networking services?
I mean networking segmentation, like it is just a bare namespace for a customer, which he can only create virtual machines without any.
I got your question. That's about implementation of VPCs. Yeah, we wanted to implement VPCs, but currently this like in beginning phase. We want to do that on the next phase. And VPCs can be implemented the same way using multus. So you just specify another, like some CNI plugin which would work with VXLANs. And you'll see another interface and the virtual machine will be connected to it directly.
And the second question would be leading to providing some VPN servicing on top of that. Do you also have any plans?
Actually, what do you mean by VPN for customers or?
Yes, yes.
Like for interconnecting their networking. We were thinking about this, and I think that everything works inside the virtual machines. Can work the same way, like with traditional virtualization platforms. So you can run your own VPN server inside your virtual machine. You can expose it through the Kubernetes network load balancer. Then user can connect to it from his own infrastructure and can access everything inside of it.
Okay.
Hi, thank you for the talk. I had a question. Are the normal pods and services are available from within these virtual machines, or is just isolated completely?
Yes, fully accessible. The virtual machines works in the same pod networking like any other pods.
Okay. Is it possible to isolate the virtual machine completely?
You can. Every virtual machine is like pod. You can isolate it by running. That's a good question. I think you can specify specific labels for the virtual machines and create specific network policy which would isolate them.
Okay.
But this is like trying to isolate some part of pods in Kubernetes from another part of pods. So this is about the same question, I think.
Got it. Thank you.
What is network guarantees for live migration? Which kind of packets we lost, so when live migration happens?
When we use our solution, it recreates the roads. Yes, some packets can be lost, but after all, if it's TCP session, it can stay alive. So I would say there might be some downtime about, I know, 0.1 second. For this time, the virtual machine will not be accessible. But you should understand that live migration is not smooth in any virtualization platform. And if virtual machine is high loaded, it can be even worse.
Hi again. Thank you for your talk. And I want to ask several questions, actually 5.
Go ahead.
Related to our task and comparable with OpenStack world. And the first one, could you explain, is that this solution, KubeVirt, I mean, already ready to provide the customer platform? I mean, do we have permission control, roles, projects, security groups?
Yes, it is using all the Kubernetes entities. Like you can control the virtual machines the same way you do with standard pods. It's just providing you abstraction for running the workload, the pods with virtual machines. The other things works the same way like in Kubernetes.
So if you will compare, is that right to understand, namespace is kind of project, can be. Namespace in the Kubernetes is kind of project in the OpenStack, for example, yeah?
Yeah, I would do that like this way. Like every namespace can have its own tenant, and for every tenant you can give namespace for run the virtual machines. For this namespace you can add resource quotas, some costs, and everything like that. About production ready, I would say that it is, but you should understand that KubeVirt is like OpenStack. It's not ready project. You can use it. Yes, it is really easy to install in Kubernetes and to try, but if you'll see the spec of these interfaces, you should understand all the aspects, like which type of front-end, back-end for networking you want to use. If you want to use block volumes or shared like mount points. So it can be really difficult for the user, for end user. But after all, I see that it works and it works nice, and I see in many aspects it can already replace OpenStack. The only thing is not implemented right now is network interfaces hot plugging. But for now, it is already implemented for Multus, for CNI. So, and there is PR for pull request for implementing this feature in KubeVirt. So I think next release will already include it.
Yeah, I also see on the source code that some OpenShift solution for the CNI also. And the next one question about the console. In OpenStack we have some no VPC console that provides, you can give it to your client and client will get in the browser console, serial console to the VM. How is it working in KubeVirt?
You mean some CLI interface or GUI?
No. There are serial console provided via HTML.
Got it.
Yeah.
Yes, Virt API can ensure that. Like, actually, you have a command line tool, virtctl, and you write virtctl console virtual machine, and you get directly into the command line interface of the virtual machine. And extending your question, is there any GUI for KubeVirt? Yes, there is, but it works just with OpenShift. You can use VNC, you have some charts there. I was trying to install it in poor Kubernetes, but it wasn't working as well.
So it will be available from the network outside the cluster, yeah?
Yes, the only user need is access to Kubernetes API.
Yeah, thank you. Next one. about the DHCP inside the pod. Am I right that you run one DHCP daemon in each pod?
Yes, exactly.
Yeah. What did you use? What do you use for this?
This is done by the. I would show you the scheme again, but it's too many slides to click. You have virt launcher. It's like Go binary, who is running libvirt, and it is also running the DHCP. And this DHCP is built in, and it's like Go. It uses Go library.
Yeah, I see. So it's inside already. Yeah. And a question about the IP addresses that you shown that you create some new resource seeder for the virtual machines. Am I right that is from the OpenStack? It's analogy. It's a floating IP network, external network, or something like that.
There are no such entities. You can create some kind of external networking using Multus. Like if you specify CNI, if you use Multus, you can specify CNI bridge, which should give you IPs from specific range, and that will work. That's actually what the Red Hat guys are trying to do. They're trying to implement the same design of networking the OpenStack has. But in terms of Kubernetes, you don't need everything. You have just anything. You just have the pod networking. And when you need to route traffic, external traffic to the Kubernetes, you use load balancers. In case if you use, if you have on-premise, if you have bare metal infrastructure, you can use metal LB.
So the main idea is to run virtual machine at any other container.
Yeah, I would say that container is just specific, just necessary entity to run the virtual machine process. And KubeVirt is doing this thing.
Yeah, thank you a lot.
Don't go away, please. We have the question in the front row. Front row, to the right.
Yeah. What's the best tool to prepare images for use with KubeVirt?
Actually, KubeVirt can reuse all the images for OpenStack. All the thing you need to have inside is DHCP client and Cloud Init, because KubeVirt also provide you opportunity to specify Cloud Init config. So for OpenStack, we can use Packer. And later, that's a good question, how the images can be stored in KubeVirt. You can store them standard in Docker registry. And how the image for KubeVirt looks like. It's like a directory inside the image. It's Docker image with /disk. And inside this directory, you just store one image file. It can be standard image prepared for OpenStack. For example, Ubuntu, CentOS, they're providing it as is. They work as is with KubeVirt as well.
I think we are running out of questions at the moment. Thank you very much. And we need a choice of the best question.
The guy was asking
with
about
5, right? So had 5 tries on that, right? But I need you to tell me which one was that.
I know. I'm telling the question about the console and how to manage it, because this question allowed me to explain how you can operate with KubeVirt from the user side.
Okay. Thank you very much. Congratulations. Thank you.
Thank you.